Okay, welcome back. Now we are looking on to the next topic, that is factors affecting the angle of deviation. Now please note students, before this, if you have seen the video just prior to this lecture, we had derived one formula, delta is equals to I1 plus I2 minus A. That is, A was also equals to R1 plus R2. So that derivation we are not going to that will not be asked in the exam, don't worry, because some of the students have asked me whether in the comment section in the previous video that whether the question will be asked to derive. So for deriving we will not be asking. We have to look into this the next part. Yes, definitely this part will be definitely asked in the exam. So the next topic is factors affecting the angle of deviation and angle delta. Okay. Now there are four factors. First is the angle of incidence, material of the prism, that is the refractive index, then angle of the prism and color or the wavelength of the light. Now let's see one factor in detail. Now first is the angle of incidence. Now here pay attention dears. First how we are going to do here. Now what we are going to do is we will take a prism, we will incident a monochromatic light, okay, and for that particular angle of incidence we will measure the angle of deviation. Okay, so now whatever will be the angle of deviation for that, we will note down both the values. Okay, and then what we are going to do, we are going to rotate the prism. Now once when we start rotating the prism, can you see the angle of incidence will also change? Now let us suppose say that we rotate in such a way that the angle of incidence goes on increasing and corresponding values of angle of deviation we go on maintaining. So all that setup and everything we are not going to discuss that over in this particular for the 10th standard class. So we will get an observation table wherein we have the angle of incidence and we have the angle of deviation, corresponding angle of deviations. Now pay attention. With that particular data, we are going to draw a graph. Okay, so this particular graph is called as the I delta curve. So in this particular I delta curve, when we see that as angle of incidence goes on increasing, if you see from the graph, can you see the value of the value of the delta is going on decreasing? Yes. Now as you go on increasing the angle of incidence, the value of delta goes on decreasing. It reaches a certain minimum value. Are you all there with me? What is happening? As I increase the angle of incidence, the angle of deviation goes on decreasing. Now we will try to understand this with a certain example. Now suppose if angle of incidence is 10 degree, let us say, this is just like an example I am taking. Let us say angle of incidence is 10 degree, and for angle of incidence of 10 degree, the corresponding angle of deviation is, let us say, it is 20 degree. Okay, so what I did, angle of incidence 10 था, तो पहले मैंने फिर उसके बाद बढ़ाया 15 डिग्री किया, तो ये मैंने कितना लिया था, इधर एंगल ऑफ इंसिडेंस इधर 30 लिया था. ओके, लेट्स वंस अगेन सी. एंगल ऑफ इंसिडेंस था 10 डिग्री, उसका करस्पॉन्डिंग डिविएशन था 30 डिग्री. दिस इज जस्ट एन एग्जांपल आई एम टेकिंग. देन एंगल ऑफ इंसिडेंस को बढ़ाया मैंने 10 से 15 किया, तो एंगल ऑफ डिविएशन कितना मिला मुझे, 25 हो गया. So if you go on noting down the values like this in that observation table, we will see that the value of delta decreases. वो कब तक डिक्रीज होगा, एक सर्टन कोई एक मिनिमम वैल्यू तक डिक्रीज होगा, एंड उसके बाद जैसे हम एंगल ऑफ इंसिडेंस को आगे वापस बढ़ाते जा रहे हैं, द एंगल ऑफ डिविएशन गोज ऑन increasing. Are you all understanding this? So see this, as angle of incidence increases, delta decreases until delta minimum, and then further subsequently delta increases. Now see this, the position at which the prism, where the position of the prism at which we are obtaining this delta minimum or the angle of minimum deviation will be nothing but called as position of the minimum deviation. Where the incident ray has delta mean, that position will be called as position of minimum deviation. Very interesting class. Now here let us take this discussion ahead. Now if you can see, only for one angle of incidence we are getting this value of delta minimum. Yeah, but for any other values, if you just check, like let us abruptly take this particular value of angle of deviation. So for this I am getting how many values of angle of incidence, this one and this one. Are you all there with me? Let's take another value, let's take this one now. So again for this I am getting two values of angle of incidence. Everyone is there with me? So for this, what is the condition that only when the value of delta is delta minimum, the angle of incidence is only one value. आपको ये समझ में आ रहा है? Yes, and then so for this, for delta equal to delta minimum, we can also prove in further conditions that I1 will be equals to I2. I1 I2 क्या होगा? Angle of incidence I1 and I2 था मेरा जो angle of emergence, जो हमने ये इसके पहले वाले क्लास में जो डेरिवेशन देखा था. Okay, now this I1 equal to I2, and similarly it can be also proved that R1 is equals to R2. Now this discussion we are not going to do it. We are just going to assume we are just considering this. इसका ज़्यादा डिटेल डिस्कशन आपको हायर ग्रेड्स में आएगा. सो I1 इक्वल टू I2 सिंस बोथ ऑफ देम आर इक्वल, सो वी हैड दिस फॉर्मूला yesterday we had seen delta minimum is I1 plus I2 minus A. Now since both of them are equal, we will get the value as 2I. तो I हो जाएगा तो बन जाएगा 2I minus A. So we got this formula for angle of minimum deviation as delta minimum is equals to 2I minus A. Okay, this formula we very important for us to remember. We will be asked numericals on this formula. Next, let's go to the next factor, material, that is mu. As refractive index increases, the value of delta is going to also increase. So there are different types of glass. So flint glass has a higher refractive index, so hence the angle of deviation is also high, whereas the crown glass has a lower refractive index, hence the angle of deviation is also low for that as compared to that. Then angle of prism A, as angle of deviation increases, angle of prism also increases. Then wavelength, this though we know now, so many times we have seen this, as refractive index depends upon the wavelength in an inverse relationship. Mu v is greater than mu r, so delta v will be also greater than delta r. So for this also, minded student, this is very important discussion over here. If you all might have seen when the dispersion takes place, like this, so v सबसे नीचे होता है, Vibgyor, okay. वॉयलेट इंडिगो ब्लू ग्रीन येलो ऑरेंज रेड, तो मैं बीच के कलर्स नहीं लिख रहा हूं, डायरेक्टली आर आई एम राइटिंग. तो वॉयलेट इंडिगो ब्लू ग्रीन आर. सो कैन यू ऑल सी? सो डेल्टा वी ई, दैट इज द डिविएशन फॉर वॉयलेट इज मैक्सिमम. सबका ध्यान है. सी ये लाइट, व्हाइट लाइट ऐसे आया, डिस्पर्शन हुआ, और ये भी तो क्या हो रहा है, डिविएशन ही हो रहा है. व्हाइट लाइट एक्चुअली ऐसा जाना चाहिए था, बट वो डिस्पर्शन, अभी यहाँ पे हमने व्हाइट लाइट यूज किया है. ये वाले डिस्कशन में हमने मोनोक्रोमैटिक लाइट ली थी, यहाँ पे हमने व्हाइट लाइट लिया है. सो दैट्स व्हाई द व्हाइट लाइट स्प्लिट्स अप, एंड ओवर हियर डेल्टा वी, दैट इज द डिस्पर्शन ऑफ द वॉयलेट लाइट, इज द मैक्सिमम, एंड हेंस द बेंडिंग ऑफ इट इज ऑल्सो मैक्सिमम. एंड वॉयलेट सबसे नीचे मिलता है एंड रेड हमें सबसे ऊपर मिलता है. ओके, नाउ वन पॉइंट आई फॉरगॉट टू टेल यू व्हाइल दिस डिस्कशन. In this, I hope you all remember this. In the previous lecture, we have already seen whenever the light ray enters, this refracted ray, okay, this refracted ray will be parallel to the base of the prism only for the condition when delta will be equals to delta minimum. So that is when the value of delta is equals to delta minimum, the refracted ray goes parallel to the base of the prism. Yeah. Now quickly, so with this particular topic is complete. Now let us quickly go to the numericals. There are just two simple numericals. We will finish them off. So now again, I don't have the latest textbook. I have the old textbook, so I will be writing exercise 4B. Hopefully the numericals will be the same only. Okay, I'll read the question. You all extract the data. A ray of light incident at an angle 48 degree on a prism of refracting angle 60 degree suffers minimum deviation. Calculate the angle of minimum deviation. Now see this, what is given to me, incident at an angle. So angle of incidence दिया है first question 48 degree, and refracting angle, that is A, is how much, 60 degree. क्या पूछा है? Delta minimum is asked, angle of minimum deviation is asked. So formula is delta minimum is 2y minus a, correct? So simple formula. So 2 into 48 minus a कितना है? 60. So this is 96 minus 60, that is 36 degrees. So delta minimum is 36 degrees. Simple question था ये. Let's go quickly to the second one. एक्चुअली ये सेम क्वेश्चन है, उल्टा थोड़ा दिया है. व्हाट शुड बी द एंगल ऑफ इंसिडेंस फॉर अ रे ऑफ लाइट विच सफर्स अ मिनिमम डिविएशन ऑफ 36 डिग्री. सो डेल्टा मिनिमम इज इक्वल्स टू 36 डिग्री, ओके, through an equilateral prism. Now see this equilateral prism बोला है. So when they are saying equilateral prism, you will have to remember A का value कितना आएगा 60 degree, and what they have asked is what should be the angle of incidence. So you have to find out. So similarly for again same formula, 2y minus A, delta minimum is 36, 2y की value find out करनी है 60. So this is 36 plus 60, that is equals to 2y. So 96 is 2y, 4i is 48 degree. So this is the same question actually, both of them. So with this, B part of our this particular chapter is over. If you have any doubts, please put it in the comment section. Thank you so much. If you have liked this video, hit like, put some comment, okay, and share it with your friends. And if you have any doubts, you can email me. This is my email address, sudarshan sudarshn.kulkrni6@gmail.com. and yes, don't forget to subscribe to my channel. Thank you so much.